Hi, we're here with our student Rita, and we're going to talk about estimating using something called scientific notation. You ready to go, Rita?
Yep.
Okay, cool. So scientific notation is a great tool to work with large numbers and small numbers. It makes your life a lot easier. So let's first talk about large numbers, all right?
Okay.
Okay, we're going to look at a really big number. Oh my gosh, let's see, that's thousands, millions, billions. That's 6 trillion, right? If you were going to do math with this number and be writing it in equations and stuff, would you want to write that 6 with all those zeros all the time?
No.
Okay, so what we want to do is we want to have a simpler way to write it. And what I'm going to try to convince you of is that that's the same thing as 6 times 10 to the 12th. So instead of writing all of this, we can write this shorter thing. And it's really simple because part of it is just this 10 to a power and part of it's just this 6, okay? That's what scientific notation is all about. So let's figure out how scientific notation works here. Let's look at an example. So if we have 6 times 10 to, not to the 12th, let's just start with something simple. 6 times 10 to the first power. What's 10 to the first power again?
10.
10, right? So what's 6 times 10?
60.
60, okay? All right, let's keep going here. How about 6 times 10 to the second power? So 10 to the second, let's see, 10 squared is 100, right? So what's 6 times 10 to the second?
600.
600, okay? Let's go one more. So do you see a pattern here developing?
Yes.
Okay, good. So if we have 6 times 10 to the third, we're probably going to have, let's see, 10 times the second is 100 times another 10 is 1,000. So what would be 6 times 1,000?
6,000.
Yeah, so it's a really clear pattern here, right?
Yeah.
And another way to think about this is how many times the decimal moves to the right. Now, let's see what I mean by that. That might sound confusing. So 6, the number 6, it does actually have a decimal. Where is that decimal?
To the right of it?
Yeah, right to the right of the 6, right? So it's kind of like 6.0, but we don't write that because that would be just a pain to write that all the time. But there is a decimal right there to the right of the 6. Now, to get from 6 to 60, the decimal moves, because where's the decimal for 60?
To the right of 0.
To the right of the 0, right? So we can kind of say that it's moved to the right, like that little bump there.
Yeah.
Okay? Now, how many times did it move? How many places did it move to the right? Well, it just moved once to the right, one place. Okay?
Okay.
Now, how about with this number here, with the 600? From 6 to 600, how many times does it move?
2 times.
2 times, okay? There it goes, bump, bump, so that's 2 times. How about down here? How many times does it move?
3 times.
Yep, okay, so it's 3 times. Now, if you notice, the number of times that it moves is the same as the power of 10. So it's 1, 1, 2, 2, 3, 3. So that's what you can understand, that scientific notation, when you're talking about big numbers and positive exponents here, it moves the decimal place to the right, the same number as the exponent of the 10. So it makes it really easy for you to understand what that number will be. Now let's talk about the rules for scientific notation. Oh, I'm sorry. First, let's go up here and make sure that this is right. So here we have, let's see, it's maybe 1, 2, 3 times, 6, 9, 12 times. So this huge number up here is just like 6 times 10 to the 12th. Make sense?
Yep.
Okay, now let's talk about the rules for scientific notation. So how does it work? Well, you have to have this first number here, like the 6. It has to be a number that's greater than or equal to 1 and less than 10. Not less than or equal to, but less than 10. And then it'll be multiplied by a power of 10. So let's give a few examples and see which ones are scientific notation. How about this one? 3 times 10 to the 5th. Is the 3 greater than or equal to 1?
Yes.
Is it less than 10?
Yes.
And is it multiplied by a power of 10?
Yes.
Okay, good. So that's scientific notation. All right?
Okay.
Let's do another example. 4.3 times 10 to the negative 6. So this looks a little trickier. There's a couple things going on. Is that 4.3 greater than or equal to 1 and less than 10?
Yes.
Okay, so that works. Now, the other thing you should know is that scientific notation can have negative powers. So is it to a power of 10?
Yeah.
It is, right? It just happens to be a negative 6, a negative power. So that's also legal scientific notation, fits the rules. How about this next one here? What's wrong with 13.2 times 10 to the third for scientific notation? What doesn't work there?
Let's see. Well, 13.2 is not less than 10.
Right. So this one is actually not written in proper scientific notation. And we'll talk a little bit about how to get something that's not in proper scientific notation into scientific notation, okay?
Okay.
But first, let's do just a quick check of our knowledge here. So 4.2 times 10 to the fourth is equal to one of these numbers over here, okay? And I want to see, like, you're going to move the decimal place a certain number here. How many times are you going to move it in this situation here?
4 times.
4 times, because that's the exponent of the 10.
Uh-huh.
And if we go 1 time, that would be 42.
Mm-hmm.
2 times would be 420.
Mm-hmm.
3 times would be 4,200. And 4 times would be what?
42,000.
42,000, right? So the correct answer is this one right here, 42,000. And you just get that by just moving the decimal place. So see how easy it is to get from scientific notation to an actual number?
Yeah.
Okay. Now, so scientific notation can help you with really big numbers. It can also help you with really small numbers. Let's look at this really small number. This might be like the number of millimeters between 2 atoms in a molecule or something like that. It's a super, super small distance, a super small number. And you don't want to write this a million times when you're doing calculations, right? So what you want is something like this. Scientific notation, a lot easier to write, right?
Right.
Okay. So let's first figure out how to use these negative exponents here. And if you remember, a negative exponent, when there's a number in the numerator, and this is kind of like 10 to the negative 1 over 1, it puts that number in the denominator with the same exponent but not negative. So that's the same as 1 over 10 to the 1 or just 1 over 10. And we know that 1/10 is the same as 0.1. So does this part make sense to you?
Yes.
Okay. So that's all that's going on with the negative exponents. So now let's look at how this actually works. So if we had 5 times 10 to the negative 1, well, that's the same as 5. Remember, 10 to the negative 1 is just 0.1.
Mm-hmm.
So what's 5 times 0.1?
5/10.
5/10, or in decimals?
0.5.
Yeah, 0.5. Okay. Now, over here we said how many times did the decimal move to the right? Here, with negative exponents, we're going to be asking how many times did the decimal move to the left. Okay? So here there's a decimal to the right of the 5, just like before, and then it moved to the left 1 time. Do you see that?
Yep.
Okay, so we can put a 1 over there. Let's do a few other examples. 5 times 10 to the negative 2. Well, that would be just like 1 over 100, or 0.01, so that would equal 0.05. And how many times did that decimal move?
2 times.
2 times. Are you noticing the pattern with the exponents here and the number of times it moved?
Yeah.
Okay, good. So then 5 times 10 to the negative 3, what would that be?
0.005.
Yep. And so I like to write the 0 in front, so it's 0.005. You don't always have to write that, though. And you can see that the decimal has moved 3 places there. Okay? So very good. So then let's look at our example up here, too. That decimal for this 5 is right here to the right, and let's count how many times that it moves up here. There's like 3 times, 6, 9, 12 times, and we arrive at the decimal. So this number up here is the exact same thing as 5 times 10 to the negative 12. Isn't that great?
Okay, yeah.
Okay, so let's go down and look at an example down here to figure out, with these smaller numbers, it's sometimes a little bit difficult. So let's turn this regular number into a scientific notation number. And remember, we have to start with some number that's greater than or equal to 1 and less than 10. So we could say, okay, well, let's see, maybe the number is 16. Well, 16 is greater than 10, right? So that won't work.
Right.
Or we could say maybe the number is 0.16. But that's less than 1, right? That won't work.
Right.
So what does it have to be?
1.6.
1.6, right? So we have to get right in there between the 1 and the 6. So to convert this to scientific notation, it's going to be 1.6 times 10 to the something. Now the question is how many somethings. We have to count how many times that decimal place is going to move to the left from 1.6 to get to this position here. And if we count those decimal places, I think it's 1, 2, 3, 4, 5, 6. So what would we write down here? 1.6 times
10 to the negative 6.
And good catch there. It's good that you didn't say 10 to the 6, because that would make it into a really big number. You have to have it be 10 to the negative 6 to make it into a really small number. Okay?
Okay.
All right, now, let's use scientific notation to compare some numbers here. I'm going to give you a word problem. Don't freak out. The planet Lucan has 2 neighboring planets. Planet A is 9 times 10 to the 7th miles away, and planet B is 3 times 10 to the 4th miles away. How many times further away is planet A than planet B? Okay, so word problems, they're always a little bit hard to dissect here. So first of all, let's ask ourselves, are we dealing with really big numbers or really small numbers?
Really big numbers.
And how do you know that? There's a couple ways you could know that from this problem. How do you know that?
Because the exponent on 10 is a positive number.
That's right. So we're not over in this territory with negative exponents. We're over in this territory with positive exponents. You could also guess, too, because we're talking about how far planets are away from each other, right? So that's probably a really big number if we're only talking in miles here instead of light years or something. Okay, good. So now we're trying to compare how far planet A is away compared to how far planet B is away. A lot of times I like to, when I'm figuring this stuff out, I like to just pretend it were a simpler problem. So I try to turn it into a simpler example. So let's say instead that planet A was just 20 miles away and planet B was 4 miles away. How many times further away is planet A than planet B?
5 times.
5 times, right? And what did you do in your head to get that number?
I multiplied 4 times 5 to get 20.
Good. Or you divided 20 by 4 to get 5, right? So that's how you did it. It's 5 times further away because 20 is 5 times as big as 4. Or 20 divided by 4 is 5, right?
Right.
So what we're going to do here, now that we tried this simple example, we're going to divide the distance that planet A is away by the distance that planet B is away. Okay? But we're going to do it with these scientific notation numbers instead. Okay? So let's go ahead and take a look here. So here's planet A's distance, 9 times 10 to the 7th from the problem up here. And here's planet B's distance. And the cool thing with scientific notation, it makes it so much easier than writing out these huge numbers and then trying to enter them to your calculator and dividing, okay?
Yeah.
What you do is you take them in pieces. So you're going to take this piece, the integer part of, not the first part of the scientific notation. These two happen to be integers, but it isn't always, this isn't an integer here.
Right.
But you're going to be talking about the first part of the scientific notation, and then you're going to talk about the second part of the scientific notation. You're going to address them separately. So what's 9 divided by 3?
3.
Okay, so we know that part, this part here is just 3. Now this is where it makes it so easy. 10 to the 7th divided by 10 to the 4th. Remember, with exponents, when you divide, what do you do with those exponents?
You subtract.
You subtract. So what's 7 minus 4?
3.
3. So that's your answer. It's just 3
Great.
times 10 to the 3. Now, if you wanted to be talking about this with your friend or something, you might say, well, planet A is 3 times 10 to the 3rd times as far away as planet B. That's kind of awkward to say that. So let's figure out, what is this in kind of non-scientific notation, regular? What would be 3 times 10 to the 3?
3 times 1,000, so 3,000 miles.
Perfect. And so we can make the statement, planet A is 3,000 times further away than planet B. And we figured that out using scientific notation without having to write out all these zeros before or after the decimal place.
Right.
Great. Good job.